Hi, welcome back to Dad and Kids Coding, where we're doing Advent of Code 2020, and we're currently on day 12, even though it's really day 14. So this is about a navigation problem, and basically our input looks like something like this. It's a sequence of moves. So F means go forward, so we can go forward, turn right or turn left, and we can move in the various compass directions. All of the moves are integers, and the number of degrees for left and right is always a multiple of 90. So it could be 90, 180, 270, whatever. And we are always, the only thing that changes the direction we're facing is the left and right turns. So we're facing east initially, and so forward 10 will take us east 10, north 3 moves us north 3, but leaves us pointing east, so now forward 7 will move us over another 7 to 17 east. Then we turn right, which means south, and then we go forward 11, so we're going to be down 8. So what we end up with is east 17 and south 8, and then we're interested in the Manhattan distance, which is the sum of the absolute value of east-west plus the absolute value of north-south. So that's 25. Okay, so let's go and look at the code. So here's the test for it. Here's the input, and we're looking for 25 as our result. So let's run it. And as usual, we get that didn't understand day 12a, so we'll create this in Advent of Code 2020. Okay, so the way we'll do this is we'll keep track, we'll have an array. So let's say distance, and I'm going to make this be an array with 4 zeros, so they're going to be east, south, west, and north. So I'm just going to put a comment here to say that. So east, west, south, west, and north. And I'm going to say that our current direction, or let's say we're facing, and we're initially facing east, so that's 1. Okay, and then when we turn, we'll move to the appropriate. So if we're in east and we turned 180 degrees, then we move forward. We change the facing to add 2, so it'd be west. If we then turned left 90, we'd move to south here. And then when we get a move forward, we'll just add to the current position. Okay, so now we are going to take our string and we're going to get the lines from it, and we're going to iterate over those. So, and once we're done, we'll just take the Manhattan distance, which is the sum of the absolute value of east, so distance first, minus distance third, and we want the absolute value of that. Absolute value, and add to that distance second minus distance fourth, and the absolute value of that. Okay, so it doesn't matter which order we do, which one we put first here or here, it's just that we want, because we're taking the absolute value of it. So that's all good. So now we just have to actually make our moves. So let's see. If let's try east, south, west, north. It's a question of what's the best way to find this. Let's look at string and see what method we might have that would be useful for us. So we want to let's finding searching. Let's see what this gives us. Find none of these look quite what we want. Let's look at the hierarchy and see what array collection isn't going to have anything useful. Sequential collection probably will. So sequential collection, and I don't see any searching, so let's just see. Find first. Let's see what this does. Returns the index of my first element for which the block evaluates as true. If none is found, return 0. Okay, that could kind of work. Just seeing whether there's anything else that includes. There we go, there's index up there. That one sounds even better. It's just the index of the first occurrence of an element within the receiver. If the receiver does not contain an element, answer 0. So that's what we want. So we'll just look in there and we'll find. Okay. So position index of, and we just want the first character of the line first. Okay. So if that's 0, so position is 0. If it's not, then we've got then we're going to move in one of those directions. So we'll do something, and if false, then it was none of the, if true, in other words it is 0, then it's one of the other ones. So let's handle those in a moment. So let's go here. So if it's not 0, then it's the index that we're going to adjust in. So we'll just say distance at line all but first as number. Oops, no, at distance at position let's get the, so let's just save this and do that up here before we do this. So number is this. So this would be distance at position. Put distance at position plus number. Okay, so that's if it is not 0, but if it is 0, then then it's either L or R or F. So if the line first is a F, then we're supposed to move forward. If true, then we want to just add this to the current direction we're facing. So distance at facing, put distance at facing plus number. Okay, so let's okay, if false, then we're either supposed to go left or right. So right is going to be positive because east to south to west. So if the direction is left, so if line first is equal to left, then the number is the negative of the number. Number negated. Okay. So now number is a positive or negative number. It's a multiple of 90. And the question is, how far do we want to turn? So we want facing to be facing. So what we'll do is we'll take the number divided by 90. So that'll give us a number of steps to turn. But we need to wrap around because there's only 4 distance elements of the distance array, so facing always has to be a number between 1 and 4. So we have to calculate it mod 4, but we also have to subtract 1 because mod gives us a number between 0 and 3. So we'll take facing minus 1. Facing minus 1 plus number divided by 90. And
sorry about that, folks. Just knocked over a cup. Good thing we have a carpeted floor, huh?
Yeah. Number divided by 90, and then we'll take all of that mod 4, and then we'll add 1 to that. Okay, so I think those are right calculations. Let's just see. So distance is a temporary, these are all temporaries. What did I just do? I don't know what I wanted to do. Okay. Save. And then let's just proceed. And, so it's not called absolute value apparently. Let's look at number. Didn't think it was called absolute value, but it suggested it, so I bought into it. Oops, I didn't want number parser, I wanted number.
That's how they get to you. Someone comes to your door saying, hey, use absolute value when you're using Smalltalk. And you're like, wow, that's really specific, but okay. Gets you every time.
Yeah, happens a lot. Happens a lot in this household anyway. So, mathematical functions. Oops. Arithmetic. Let's try arithmetic. Hello? Arithmetic?
Yeah, arithmetic is hard for abs. Arithmetic is hard for computers too.
Right. So it was just abs. I thought it was abs, but I got confused. Okay. Save and proceed again. So we got 25 for the first one, so we might be doing the right thing. And we got 22, 28 for the larger data. So let's see. And now this succeeds. And go over here and try this here. And it's the right answer.
There we go.
So continue to part 2.
Okay.
Before we can give the destination, you realize the actual action meanings were printed on the back of the instructions the whole time. Almost all the actions indicate how to move a waypoint, which is relative to the ship's position. So all these say to move the waypoint north, rotate the waypoint around the ship left, rotate the waypoint, F means forward to the waypoint a number of times equal to the given value. Okay. Starts off 10 units east and 1 unit north relative to the ship. Waypoint is relative to the ship. That is, if the ship moves, the waypoint moves with it. For example, using the same instructions, F10 moves the ship to the waypoint 10 times, a total of 100 units east and 10 units north, leaving the ship at east 100, north 10. The waypoint stays 10 units east and 1 unit north of the ship. And 3 moves the waypoint 3 units north and 4 units to 10 units east and 4 units north of the ship. Ship remains at east 100, north 10. F7 moves the ship to the waypoint 7 times, 70 units, leaving the ship at whatever. The waypoint stays wherever R90 rotates the waypoint around the ship clockwise, moving it to 4 units east and 10 units south of the ship. Ship remains at east 170, whatever. F11 moves the ship to the waypoint 11 times, total of 44 units east and 110 units south, leaving the ship at east. Whoa, okay. Not sure I completely get this, but okay. So.
Well, if you don't get it, you can kind of see it as a the ship's for you teleporting, and the waypoint is like a icon demonstrating where the ship will go every instruction.
Right.
Or at least every forward instruction. And the other different commands decide where the waypoint will go.
Right. So forward is the only instruction that actually moves the ship.
Seemingly, yes.
And the others all move the waypoint around.
Yes, the action is the only one that... Yeah, F is the only one that actions the waypoint teleports, and the number is how many times it teleports.
So... Okay, well, let's... 12. No, of course it didn't. Let's see if we can figure this out. So let's go and look at the code for day 12A. So we need this distance thing the same as we had before. We don't, well, we need, so we don't need facing. So we need similar code to this, but completely different. In that we have the same direction, so we'll parse it the same way. It's just what we do with them is different. So I think what we need is two facing. We need the I think we're going to pause this here and we'll pick up the video after I want to think about this bit. And because it's probably no more fun for you than it is for us to have me going, I don't know exactly.
Yeah,
so
if you wanted that, you watch the international chess tournaments.
There you go. So we're going to save this here and we'll resume a bit later. Okay, take care.
Bye.